So we have been hearing so much about project funding, doing research, but doing research in collaboration is absolutely important. And to talk on this topic, we have Dr. K Gunasekaran sir, who is the professor in civil engineering, head of division of transportation engineering at Anna University. So sir has his BE civil engineering at Government College of Engineering, Salem, 1986, Masters in Urban Engineering, Anna University, 1991, and PhD in Transportation Engineering, Anna University, in 2003. He is also a visitor to University of Canterbury, Christchurch, New Zealand for a period of 6 months. So sir's area of interest is public transport, road safety, traffic engineering, and transport planning. With 30 years of teaching experience, he has carried out 6 sponsored research projects, including CSIR CRRI sponsored development of Indian Highway Capacity Manual. He was the coordinator for 40 studies of state government departments. Sir has published his work in 16 national and international journals and in 30 national and international conferences. He is currently guiding 6 PhD scholars, and his 3 students have already completed PhD under his guidance. We are very glad to have you, sir. We hope that your ideas on collaborative research will be helpful for our scholars. Before that, I request our director, madam, to felicitate the resource person for today. So please accept this small token of our love and appreciation from the Center for Research. We welcome you, sir, to this induction program. Thank you, sir. So the session starts now, and it will go on till 12:45. There will be a small question and answer session towards the end. Thank you, sir.
Good morning. Though it's a slightly late afternoon, we'll start with a fresh talk. So I heard about the sessions that are ongoing, and really I feel you're all a little bit lucky. You are guided how to proceed in a structured manner, how to take up the program. So when we do ME and all, we know it is 2 years, BE it is 4 years, or BSc it is 3 years. It is a definite period. We know when the class will start, when the semester will end, and when we will have exams and all. But when we start a research, we are just given the, maybe if you are in the PhD program, you are given the admission letter. If it is a project, we are just given the approval letter. Though they say it is 3 years or 2 years, we don't know how to plan our activities in the 3-year period or how to go about during the PhD program. So that will be the general ambiguity when there is a research. So if it is a defined program, we know how it will be in a structured manner proceeding. But when it is a research means we are not able to define exactly, because there are a lot of ambiguities in our what is called as program, and our activities in life will also be having a say in the continuance of the program. So here I just like to share the experiences on collaborative research. I am from the civil engineering department. So we have a division called transportation engineering. So travel, I think it is an integral part of everyone's life. So without travel, we cannot lead a life, and our development to a majority extent depends upon travel. So whether we like it or not, we have to travel. Okay. So I am just trying to highlight what are the recent developments and how it has been possible because of the research efforts of many people, how it has come into reality. So it is not just like a basic research, it is just an output of the application research that has helped the transportation to make our life easier. So when we just open the newspapers, or when we switch on the TVs, or just when we hear our budget speech, we come across terms like smart city. So Chennai has been approved as a smart city, Trichy is approved, Coimbatore is approved. We hear the word smart city. We think our life is going to transform in one day. And when we go next day, everything will be smooth. But it is a long process, and it is an output of many people's effort, and it is a gradual process, and we are also in the evolution path. We are not just adopting from the developed country. So what we have in developed countries cannot be as like that implemented here. So there are certain restrictions. We'll see how we are able to achieve this one. We are having other terms like shared mobility. We want everyone to go in a bus or metro when there is congestion. So when we have Deepavali, especially in Chennai, everyone wants to go out of Chennai. Pongal, everyone wants to go out of Chennai. And suppose when we want to go from Chennai by bus means, if we get a seat, especially during the weekend, especially during long holidays, we are a little bit lucky. But if you are just talking to people, how much they are spending to take their family for long holidays, it will be just like a horror movie, okay? How they went, how they came, and whether it was a peaceful journey and all. It is really like a horror movie, okay? But still we want to travel. So we want to see that our travel is shared in a public transportation in a comfortable way, how it could be done. So we engineers and planners has to find out how it can be done. So next we have sustainable mobility, what is called as the safe environments. When you are just looking at the carbon monoxide level or hydrocarbons and other pollutants level, the concentration in the cities is really very high. So we come across a lot of respiratory problems. Our kids are also going to have respire the same air, and they are also going to have a lot of respiratory issues. So we want to have a sustainable mobility. So we advise everyone to go by walk, everyone to go by cycles, but unfortunately we don't like to follow that one. So that is the mentality. And we also want to see that everyone wants to travel safely. So when you go out, when you come back, we don't feel the safety issues. Suppose if you are just talking to people who have fell down from their bike or just hit by a bike from the rear side, or one who has fallen in a pit on the footpath, he will tell what safety means, okay? So he will be bedridden, he may be there for 1 day, 15 days, 6 months, 1 year, and really when you talk to him, then you will realize what is safety, okay? So if you are just looking in the movie, someone is affected, we don't feel the pressure. But when our close friend is affected, when our relative is affected, when we ourselves are affected, we feel how it is important, okay? So we are losing a lot of lives, especially in Tamil Nadu. We are losing around 15,000 lives per year. So we want a safe mobility, not only a comfortable travel, cheaper travel, we want safe travel. So we are aiming for all these aspects, and we are trying to use the technology for achieving this one. So though we have the police for enforcement, speed enforcement and other things, but still we are not able to implement 100%, and we plan for a system that is a comprehensive system called as intelligent transportation system. So it involves the efforts of the research output from the people from electronics discipline, media science, that is video analytics and all, data analysis. We have huge data, and it is really a challenge for you computer experts to work on data. Then the transportation group, transportation engineers, transportation planners. Then we have the help of statisticians to have the models and go for an interpretation. We have using the GIS expertise, automobile technology, architecture, and the list is endless, okay? So the efforts of all these people has come out of a system, and gradually the Chennai is going to have this system, and we are also going to have the system for Madurai and Coimbatore, okay? With respect to our near vicinity, these are the 3 cities. These systems will be implemented in near future. Maybe in the long run, we will be come across for even for small cities and all the regional network also. So there are many components in an ITS. One is incident detection, how to detect some event on the road, like an accident or a congestion or a VIP movement, some weather, and how to inform the weather to the people. And if you are not expecting, that is the bus you are expecting is not going to come on time, how to get the information so that I have some reliability on the bus service and I am able to travel. How to see that the vehicles are traveling in the lane itself, and then how to pass information from one vehicle to the other, vehicle to the infrastructure, that is connected vehicles, car sharing, how to go for a payment mechanism, automatic payment mechanism. When you just look at the conductor, he issues the ticket. Sometimes the bus stops in the middle just to see that everyone has got a ticket, okay? So we want to see that there is no conductor. You just keep the card, automatically you are given permission to enter, and there is no requirement for additional manpower because all our transport corporations are running on loss. We are not able to pay the salary to the people. We want an intelligent parking system. When I go to T Nagar, I don't like to go round and round. I want to be informed where a parking is available and how much, what is the parking charge. I don't want people to just park their vehicle for 1 day or just 8 hours, 10 hours indiscriminately. If it is free, we do that, okay? So I want to manage the parking. I want to manage the traffic. I want to identify who is violating, and I want to see that the roads, the discipline is followed, everyone moves in a schema, what is called a seamless manner and also safely. Okay, that is the aim of the system. We'll just see one by one. So if you are just looking at the overall system, so what happens in a system if ITS is implemented? So we want to see that the information of arrival of a train is informed to the what is called as the bus passengers, and the information of a vehicle is informed, the distance between the two vehicles is informed to the other vehicle, to the signal controller, and the communication happens between one system to the other and one vehicle to the other and one vehicle to the infrastructure. So this is just a schematic diagram. So when we just take the components, we have the what is called as intelligent traffic routing, then traffic management, then simulation, then identifying violation, then we have what is called as data-driven decision making, that is the overall process. We have incident detection, dynamic traveler information, and real-time congestion, how to identify that and see that our vehicles are able to travel in a peaceful way. So this is just one technique that has been put in practice. So we want to see that the driver is guided, he is in the lane. So whenever you are just outside the white lane, you are informed, you are crossing, you are stepping in somebody's lane. So you just come back to your lane and you are seeing that you are moving in the lane. So we have a system, we have the video cameras, we have the radar system fitted in the vehicle, and you are just guided that you are keeping to your lane. So this is just efforts of our what is called as our media science group and electronics group, and they're gone for how the digital cameras will work, the technique, everything. It has been evolved with the efforts of a lot of people, and we are enjoying the facility. And when we just look at the cameras, radars and all, you are informed what is the distance or the clearance between two vehicles, especially lateral clearance, longitudinal clearance, so that when you apply a brake, you are a little bit alert and you don't want to see that the other vehicle just bumping on your rear side of your vehicle. Okay, so this helps you in driving. So in a way, we are made a little bit lazy, but we are seen that you are able to drive safely. Okay, so the system is in process, it is already in application. The next one is when you are traveling on the national highways, you can just see a board. It is called a variable message sign or dynamic message sign. So you are informed whom to contact in terms of an emergency, what is your speed limit and all. But it is not the end of the story. You will be displayed what route to take, how much time it will be to reach from one point to the other. It can be displayed on a notice board or it can be displayed in a variable message sign. And if there is any traffic block or an accident, you will be informed what are the problems in the ahead, whether you can choose an alternate route. So you will be informed through the signs. So it is a display technique that is adopted, and it is having connection from the control center and you get the messages. Okay. So this is some of the messages that normally you are putting to. Don't think it is all in abroad. It is implemented. It's working in Hyderabad. It is partly working in many cities like Mumbai and Delhi. Okay. So don't think it is from any developed country and we are not trying this one. So gradually we are implementing. Maybe in a span of 3 to 5 years, we will be having all these facilities. So you get real-time information. So what will be the time it will take to reach the other end or a destination, and whether you have an alternate route, and how much distance you have a metro, and how much time it will take by metro. You are informed so that you can select your own vehicle or auto rickshaw or a taxi or a metro. Okay. So next one is, this is for our electronic friends. So we have come across frequently dedicated short range communications systems. Okay. So just like Bluetooth, and we have many mechanisms that we are able to pass the information from one vehicle to the other. So when we just look at the vehicles on the road, we are not literally able to count throughout the day, throughout the year. So when we have a system in which one vehicle talks to the other and you get the information how many vehicles are in communication, then you get how many vehicles are present there, what is their speed, and what is the type of vehicle, who is traveling. So everything, it is all really possible. So we have our Bluetooth, so it is possible even to communicate with Bluetooth, and we are able to get the information. So the short range information is a revolution that is happening, and it is gradually used in the transportation field for communication between vehicles. Okay. So what should be the spacing between vehicles, whether it is safer for that particular speed, or you have to increase or reduce the spacing, you will be able to get a what is called as an instruction, based on this one. So this is the total communication connected vehicle has. So it not only has to the nearby vehicles, it also has to the mobile towers, to the through the our satellites that are available, so mobile phones, and we can also connect it to the office where you are and how you are reaching your office. So you get the total information. So connected vehicle just means one vehicle to the other is connected. It is just a communication with the what is called as the office and other facilities. So when we just look at the facilities, we have the systems in which you are able to communicate within the vehicle itself, from one vehicle to the other, then vehicle to infrastructure. So these are the three items in which this short range communication is used extensively. I think we have a lot of scope for applying a technique and whether it is suitable for our conditions. So when we get a technique, we cannot simply believe it will 100% work in our conditions. So we have to check and whether it is suitable for our condition and whether it will work perfectly. We should have a review, trials, test beds, and then only go for implementation. So when you're just entering the campus, especially through the main gate, we have a mechanism called as ANPR cameras fitted in the gate. Okay. So what we have done is, we have seen that all the registered vehicles are given an automatic entry, and when a new visitor comes, he is stopped there, the gates will not open, and you have to just make a entry to the security, and then only you will be permitted inside. So that is the mechanism we are planning. We have put a test bed, and we put the test bed and we are calibrating for nearly 2 months. We came across a lot of issues. So we are able to detect the ANPR. So ANPR is nothing but automatic number plate reading cameras. Okay. So it detects the register number, matches the register number, and if it is a registered vehicle, it automatically opens. So ANPR cameras, so we fitted for the four-wheelers, it was working perfectly. So all the cars had a register number written perfectly, you are able to detect. But when we started for the two-wheelers, when you are just looking at the front number plate of few two-wheelers, you can see everyone is at different height. One is inclined, one is tilted, one is perpendicular, and we were only 5% successful in detecting the two-wheeler number plates. So what we did was, we changed the camera position to detect the rear side view of the number plate of the two-wheelers. Now we are able to get 95% of the registered number of the two-wheelers, and we are able to see that the system is configured. Okay. So ANPR system is really a good system, and it is automatically installed in the parking lots for the safe campuses, and it is really working well. And it is also based on the what is called as an output of the research from many of our electronic group people. So when you want to just have a vehicle identification, it is also having what is called as RFID technique. Okay. So RFID, passive and active RFIDs are available, and how to use it, there is some limitations and challenges and advantages. So it needs to be explored when you are just trying for our campus or for a town or for a city. Okay. So why we need to go for automatic vehicle detection? What is the need for it? So you must have read in the newspapers. So if you are jumping a red line, your number will be automatically stored and you will be issued a challan. So for that purpose only, these techniques are on trial. Okay. So ANPR cameras, it will be working very well when you are moving at a slow speed, and when you are moving especially in a car or a what is called as four-wheelers. But when you are moving in a two-wheeler, there are certain challenges. So that is why you are getting an RTO notice frequently. Your number plate should be as per our transport department standards, and soon the government is going to issue a notification. If your number plate is not as per standards, you will be put into fines. Okay, you will be levied fines. It is for no other purpose, only for detecting you whether you are violating any violation, traffic violations, and if you are jumping, automatically it will be caught. Okay. So there are some studies that is already done. When you have techniques, you have to go for a comparison, how the technique will work, what will be the range, what will be the cost, and how it is working for the 2-year expectations, and what is the durability of the system, and how well it will fit. So the other technique that we are generally using nowadays, or popularly using nowadays, is fitting of a GPS in the buses, and what is called as issue of tickets by ETM, electronic ticketing machine. So electronic ticketing machine, you think the conductor is benefited. No. You are observed where you are starting and at what time you are starting and where you are ending your trip. Okay. So when you're just thinking in Chennai, 30 lakh people are traveling by bus every day. So imagine 30 lakh people's travel movement without personal identification, the data is available. So I know how a person travels on a working day, how he will travel on a Saturday, how much travel happens on a Saturday, how much travel happens on a weekend. I am able to observe with the ETM data. And with the GPS, I know how much time it will take to reach from one point to the other during morning hours, evening hours, and direction wise, I am able to get it. So this information, it is not only passed to the what is called as passengers, the expected arrival time of the bus, but it also helps you to plan the operations so that people doesn't wait for longer period. So this is just one of the system that is implemented in our MTZ. So in MTZ, you are having all the buses fitted with the GPS. You know where the bus is. So sometimes at night 11 o'clock, if you are just looking or standing in front of Anna University, you can see 421G going together. But now if you just go there and stand, you will not have a 21G for another half an hour. Okay. So to know exactly when the bus will arrive, this GPS data is used, and it will be certainly a boon, not only for us and for many people to travel by buses. And if many people travel by bus, the number of vehicles on the road will also be reduced, the congestion will be less, and we will be having less pollution on the roads. So the benefits are really manifold, and it is mainly, it will become feasible only with the help of the technology that is being put into practice. So this is our GPS data. You get the latitude, longitude that is passed on to the control room for every 10 seconds. The polling rate is 10 seconds. So the data or position of the vehicle is passed on for every 10 seconds, and you know where the vehicle is and how it is proceeding. Another thing is, so there are 21Gs, nearly 30 number of 21G. I am just taking the example of 21G, which applies from Tambaram to High Court. It goes via Anna University. Okay. So we observed the buses, and what we found was, okay, clear. And what we observed was, so what happened was, when a bus starts at 6 o'clock in the morning and another bus starts at 6:10. So the third bus starts at 6:20. So imagine you are traveling in the first bus, your another friend is traveling in the second bus, and another friend is traveling in the third bus. Okay. So when you are just seeing, you are coming to Anna University, you are getting down first, and the second friend has to come down as second person, and third friend has to come as a third person. But when you see the third person coming first and you are coming last, means you feel terribly upset. You don't like MTC at all. Okay. You will not travel by MTC buses again if you have an experience like that one. So we want to see that all buses are going with the uniform gaps, all drivers are driving perfectly. The delay may be due to driver fault. He will be skipping certain stops, whereas the drivers will be stopping at certain stops. So it may be due to several reasons, and we are trying to find out whether all buses are going with the uniform gaps. The monitoring is possible. It is possible only with the help of GPS. Okay. So this is our ticketing machine data. So ticketing machine data, we know where they are starting their trip, where they are ending, and how many passengers have got the tickets, what is the time at which they have purchased the tickets, and what day they have purchased the tickets and all. So again, we took the data and we just tried to find out how many people are traveling per hour or by different buses. We can see that the maximum crowd is at a particular time, and other time we don't have the crowd. So what instruction that is given to the drivers is, run 8 trips. Crowd irko illiyo, you just run 8 trips. So the driver drives meticulously without bothering about the crowd. But when a bus doesn't come in the peak hour, people are moving away from bus transport and leading to a lot of troubles. Okay. So we have congestion, we have again pollution, safety issues and all. So we analyze the data and we are able to see how many people are traveling, how many people are traveling on a working day, how many people are traveling on a weekends and all. And once you get this data, you are able to plan your schedule so that you are able to see that the service is best and reliable for the people. So this is just one display of the what is called as the bus passengers of Viluppuram Transport Corporation. So we did a study for Viluppuram Transport Corporation. So it is in nearly 5 districts from Chennai to top down up to Viluppuram, Dindivanam, and it goes to almost Trichirappalli. So we just observed how many people are traveling by through TNSTC Viluppuram buses on a working day. We know what is the flow and we can operate the buses according to the crowd. Okay. So it is all possible from the ETM data, which has been, it is a small device. It helps us in analysis, and it is also a challenge. It is a big data that is going to be available for transportation, and it will be a good tool for play with for the computer science engineers, okay, and researchers. So there is a lot of data that is available. If you are taking Chennai, 30 lakh people are traveling in Chennai per day. We have another 5 lakh traveling by suburban trains, another 2 lakh traveling by our metro rail. So how they are traveling, where they are traveling, you get the information, you'll be able to plan better. Okay. So this is one thing that generally that is in operation now. So the other one is the traffic management. So when we just look at the traffic management, we come across what is called as the signal design, signal coordination. So we have what is called as the signal design. So signals, it is really what we see on the road is a basic signal that we have. So traffic signals, when you just move at night time or daytime or peak hour, we can see wherever there is a crowd or there is no crowd, the green is for the fixed time and the red is for a fixed time. So night when you are coming and when there is no vehicle on the other side, and if you are made to wait, you lose patience. Okay. So you like to have a red light jumping, and when you are caught with the system, you feel that your system is not perfect. Okay. So we want to have a system which automatically will detect how many vehicles are there for each moment, allow green time so that these vehicles can move with the minimum waiting. Okay. So signals are there. We'll see how the traffic signal scenario is going to change in the coming years. So when we just look at the signal systems, we have the fixed time signals. So it is an individual controller. It doesn't worry about how many vehicles are there. So green time 20 seconds towards Anna University, 20 seconds away from Anna University. It is a fixed time. Either it is morning, evening or something, working day, holiday, it doesn't bother. The time is already set, it will work accordingly. Okay. So the next one is what is called as you stop at every signal. So each signal there is no communication. When you just move from the next signal, again you wait there and you are able to just move only when you get a green here. Okay. So what attempt has been made is what is called as coordination, signal coordination. So when you move at the same particular speed, all vehicles are moving as a bunch, you get the green at the next signal, and the next signal also you get a green. It is like a green wave. Okay. So it is like a green wave that is possible, and you get the green coordinated corridor. So the next advancement is what is called as vehicle actuation. So it detects how many vehicles are present, and it allows the green time according to the number of vehicles waiting. Okay. So that is vehicle actuation. The second one, it is applied to the signal coordination, and it is also applied in the CBD. In whichever direction you move, you are able to get a green wave. Okay. So that is how the system is evolving, and it is a transform, and we come across what is called as adaptive signals and all. So these are fixed time signals. So you keep one timing in the morning, one time in the evening, and it works on a fixed time. And vehicle actuated, it modifies the green time according to the crowd that is waiting. So it is all done with the help of the sensors, and when you just see how the crowd is moving, it is all observed. So it is really a good tool or good area for the statistical group to work on, and observing all the traffic, how it moves, whether it moves as a bunch, and if it is all cars, how they will move, car plus two-wheeler, how they will move, car plus buses, how they will move. You just make a study and see that the signals are coordinated in the best possible ways. Okay. So this is one type of system that is already installed. It is in Kamaraj Salai. We can just see a small cameras at the top. Okay. So they are nothing but the cameras that will be at a narrow angle and wide angle. They are watching you, and they are just finding out how many people are in the front, how many people are just coming towards the junction. It automatically sends us. So the camera sends by means of what is called as virtual loops already in the cameras. It sends us, it identifies how many vehicles are waiting. It passes the information to the controller, and the green time is adjusted for that one. Okay. So these are all called as vehicle actuated controllers and sensors. So these systems are gradually implemented, and the capabilities of the cameras are also what is called as, it is as per the height of the pole and according to the junction layout. So standards are available, you can just try this one. So we have also tried some studies for the Kamaraj Salai, but there are certain restrictions with respect to technology and all. There are advantages, and that is being tried. Okay. So we just tried on the Kamaraj Salai. So the next one is parking management. So when you just go to Chepak, and we had the one-day test recently. So when you just go there means you'll be finding what is parking, what is the parking problem. You won't find a space for parking. Okay. So if you go to T Nagar, though it is only a small area, but if you go for a big event like our cricket match, you will feel really what is the parking demand. Okay. So you just go there, find a lot of difficulty, and you are sensed how many vehicles are entering, what is the space that is available. Now we just go to the multi-level car parking in T Nagar. You are sensed what is the parking lots that is empty and what is the parking lots that is occupied, how much time you are charging, everything is recorded. Okay. So this is also one system that has come out of the intelligent transportation system that is available. And also environmental studies are done for big projects. So this one study that has been carried out for our Omandurar estate. Previously it was a assembly building. So now it has been used for a different purpose. So traffic management, how the roads has to come. So we traffic engineers use all these techniques to find out how they can be applied and how they can be used for data collection and what management measures is required. And also everything cannot be tried on the field. When have a new technique, we just try to go for simulation. So I think when you're just talking to mechanical friends or just like a video gaming, we also use the same simulation plus video gaming to find out if you are making a system, how they will work. Okay. So we simulate the field conditions and find out how it will work and what modification is the best one if you are not able to find out the system or design a one by means of our equations that we are having. So simulation, sorry I don't have the video. So you just try different forms how the traffic can move around Madhya Kailash and find out which one is best. You can go for measurements as you are doing on the field and finally find out which one is the best one. Okay. So simulation is also used extensively, and it has been used extensively for traffic studies and for traffic planning. So finally when you are just coming for safety, we know it is a really whatever, even one accident you are preventing, you are saving a life. And if you are able to save the lives means it will be really what is called as prevention is better than cure. And what generally is done is GA is used extensively to find out the accident location, to find out the black spot, find out the reason, what is the reason for accidents. So it is called a collision diagram analysis. So whether it is a rear end accident, then right angle accident or a side swipe, what is the different type of accidents, you go for an analysis, detailed analysis of each black spot, find out the solution, and finally when it is implemented, accidents come down. Okay. So just the last one or two slides just to see what are the systems that are sensors that are available in a car. Okay. So if you just look at the modern car, we have many sensors. So previously we had everything mechanical, now it is electromechanical. Okay. So we have many sensors. Even when you just look at our rear view cameras, it helps us a lot. Okay. So we must have read in newspapers earlier, when a bus takes a reverse, when a child comes, he is run over by the bus. But now once you have the rear view cameras, these type of accidents are avoided. Okay. So each sensor helps you in safe driving, and the technology is not only in the vehicle, it is also on the road, and it is also implemented extensively so that you have a safe driving. So many developed countries not only use these techniques, but also teach the children to obey the rules. So it is just a small slide to say we have also to obey the rules and see that we doesn't violate. And they are also educated how a vehicle, what is the braking distance and all. So when a fast moving vehicle comes, whether you have to cross a road and whether it is safe to cross a road, so you are educated by continuously, and finally you are made to move safely. Okay. So here finally, just before the final slide, so transportation is an area, it is a totally interdisciplinary area. So we use the expertise of electronics, statistician, and we also work with administrators like police department, Chennai corporation, planning agencies like CMDA, and really it is an effort of the teamwork, and it is the output of many researchers from different disciplines that is being applied on the field, and the application aspects are studied by transportation engineers, whereas it is the hard work and efforts of many electronics and media science people that is on the field, and we are going to enjoy the benefits maybe in the short range that is going to come. So with this, I am just concluding my speech. If there is any clarification or further points, you can just add, and we will be happy to hear from you. Thank you.
Any questions from the audience? One or two questions?
Okay. Thank you.
I think it was highly technical, sir. That's why people are very calm and quiet at their
The thing is, I am not going too much into transportation.
Yes,
it was
yes.
little bit an application which I pointed out.
But
Only thing is, just to have an impression, what we are working in the labs, it's not a waste.
yes,
So what you are just trying using your video analytics or sensors, it is gradually getting transformed into field, and transportation is one area that is using extensively all these applications.
Yes, sir.
That is what I want to highlight.
Yes, sir, you are absolutely correct, sir.
Yeah.
After seeing your presentation only, we came to know, see how much this projects and research are very much related to the society. How people are working for the effective traffic management, all these things we are able to see from sir presentation, and we are very thankful, sir. Actually, immediately you have accepted our invitation and you presented it very nicely. Any questions or anything? Yes.
Hello. Sir, I am Penelope,
Yeah,
working
please.
as a scientist in Samir Center for Electromagnetics. I am here in Department of Electronics. I just want to ask one question, sir. It's nice presentation and work also. Like you were telling about 30 lakhs of data. So how you could able to manage those kind of data? Any kind of data analysis and storing you have implemented in that? That I just want to know.
Yeah, actually, we are working with our computer science group. And normally, one thing that we have to go or a little bit learn in our life is, let us not try to step into somebody's shoes. I am a civil engineering transportation guy. I don't want to work or learn big data analysis and use it. I have friends who work on big data analysis. Take their help. So I use the outputs which they are giving for my inference and take a decision. So I take their help and use it. Sorry, I am not able to answer you directly what techniques they use. Okay. So, but we take their help. So that is why we say when you are working as a group or interdisciplinary group, the output will be faster and really it will be useful. But if I learn big data analysis and if I try to use it means it will take a longer period. I will share my experience. I showed the case of Viluppuram. It was a study given by the government to us. So when it was 2011, I think, the fare was revised. Bus fare was revised from 3 rupees earlier, our normal ticket, to 5 rupees. There was a drop by nearly 30% people going by buses. So they expected some revenue, assuming all will be going by buses, even you are increasing the fare. But what happened was, there was a 30% drop, and what revenue they were earning earlier, the revenue now they are getting was slightly higher. It was not the one they expected. So we were asked to explore what is the reasons, how they can be pulled back again to the buses. We went for a detailed study. So when you are just looking at the data, it was nearly a 2500 into 2500 matrix. Okay. So each bus stop we coded. Chengalpet we coded as 1, gave some numbers. So for Tambaram we gave another number. 2500 bus stops, we gave each a particular identity, and we know from 1 to 7, 1 to 5, like that. We just brought everything into digital form. We prepared a matrix, and finally we took the help of GIS, and finally we displayed on the map. It was understood easily. But that one map, it took 7 months hard effort of nearly 6 to 7 people. For one example, I will say, when you go to the field, you will not be getting the answer directly. For Chengalpet, the spelling was in 32 styles. Okay. So 32 buses, 32 depots, they used different spellings. And Chengalpattu, if I type means I get 32 spellings. So eliminating all the errors, really it is a patience, it checks your patience, but it will be challenging, and finally the result will be awarding for you, and you will be getting satisfied once you use all these techniques. Okay.
Thank you,
Manually it is not possible. So we have the techniques, let us use the other people's techniques, what they are really working on, and let me enjoy. So ITS, if you are just looking at, it is a hard work of many people. So I want to just highlight, it is not the work from anyone from transportation. We are just applying. So let us apply, let us see that our results are precise, and it is a need to work in a collaborative way. So that is what I want you to just understand based on this lecture. Okay.
Thank you, sir.
Thank you.
So thank you for that session, sir. I was looking at you as a researcher who was presenting the work very passionately. So I think our own researchers, when they are presenting their work, how much of data you must be able to present, how much of authentic ideas that you must present, you can learn from sir's presentation. Sir, I do not know how relevant this question is, but I'm going to read it anyway. There is a question that this person is 6 feet tall, and for past 40 years, there is always a struggle to get the knees between the space in the seats. So how can we do this, he's asking.
Sorry?
So this person looks like he's a very tall person. So bus design also, if there is any flexibility in design, is it possible, he's asking.
Yeah. Maybe how we generally go is, suppose say for at a signal, we assume that we calculate a walking speed. So what in front of Anna University, what we generally do is, we know the total width that we have to cross is 15 meters, and 15 meters, how much time it will take for average person to cross. So what we generally do is, we make 100 people to cross, and we find out how much time 85% of the people take to cross, and that value we take it for design. Similarly, the question from the person, what we generally do is, 85% of the population, what is the height, we take and we design it. Maybe special cases, if there is what is called as forwarding, it will be incorporated. Certainly it can be done. But generally when you are dealing with human behavior, we take the 85th percentile value. So that is how all our designs are carried out. For an average human being, what all is required, it is all incorporated in the vehicle and on the road.
So your topic of today's presentation is collaborative research. Can you highlight your experiences? Saying few, actually you have presented, but I think most of our research scholars, they are not able to understand what is the collaborative research that you have carried out.
Suppose say for example, let us take the management group. So management group, they are studying in the user behavior. So when I put a system, when I put a signal design, or when I put an ITS on the road, so as a driver, so immediately just take the case of our gate, ANPR cameras at our gate. So previously you are driving casually, freely, now you are put into small restriction. So people don't understand, it is for the safety, the benefit of all people who are entering, and what they do is, initially their reaction will be opposition. So initial reaction will be 90% opposition for any scheme on the road. It is not only for our ANPR camera, it is even for the flyover at Kathipara. So they will say, I was going peacefully at the same level, now I have to climb up, climb down, turn left, right, I don't know where to go. That will be the immediate reaction. 90% of the people will oppose. After 1 week, the opposition level will come down to 40. Maybe at the end of 1 month, everyone will like it. So management people, if they study the human perception, what they think about any project, and if they analyze and say, this will be how the people's reaction will be for a new project, then the implementers will be really happy. But when I implement a system and tomorrow everyone talks against it, means I feel really bad. So that is where our sociologists and our MBA people can help us. And as I told, regarding the data analysis, we have large volume of data. So data analysis, especially our computer science group and all, they do a lot of analysis, they have not a lot of techniques, genetic algorithm, AI, for prediction and all. So let them use the data and come out with a solution based on our requirements then it can be implemented in a best way. I will know how many buses I need in the morning, how many buses I need during peak hours, how many buses I need in the evening hours to disperse a crowd during Deepavali. I will know only if the large volume of data is analyzed, and that too analyzed after storing for 10 years or something like that, my decisions will be more perfect. Okay. So, I have just highlighted we are dealing with a large volume of data, and a large volume of data is really a challenge for our data analysts who are really working on different disciplines, and also video analytics. The challenge is traffic police thinks if you are just putting a camera, the all violators can be caught, but one is going at 100 km/h speed. I think you know the digital camera. So, if you are still, your image is perfect, you are moving, your image is blurred. Okay. Same thing applies for the traffic on the field. So, if you are moving at 20 km/h speed, the detection is perfect. You are moving at 100 km/h speed, you are not tracked. Okay. So, all this, it is all areas for research from the field to the what is called as a lab, and again from the lab to the field, it has to be transferred so that the system will be working perfectly. So, that is what the thing that one has to understand from our talk.
So you had some computer science students involved.
We are working with computer science people,
and
we are working
also
with video analytics people.
So many of our research scholars are now watching our lecture. So is there any chance of selecting some topics related to transportation?
Yeah. So currently we are
for the other scholars.
Yeah.
Say for example ECE or other branches.
So for ECE we are working on what is called as image processing. So what we did was we tried to identify how many vehicles are moving with cameras. So we located the cameras, and the cameras were at an angle. You are not able to detect the other vehicle because of shadows. If a bus and another two-wheeler is on the side, if you are having the camera from the side of the bus, you won't be able to get the image of the two-wheeler. So we found that our drones are the best one to have the top-down view. So we flew nearly 5 drones at a height of 200-meter height and captured the image of the traffic, the video recording of the traffic on the road. So we took the help of our electronics people to identify from the video whether it is a two-wheeler, whether it is a car, and to track at what speed it is moving. We have taken the help of our image processing group. They are working on it. So there are a lot of techniques like YOLO and all. So I think the people may be working on X-rays and all for medical electronics. Now they have a possibility of working on the traffic. So that has to be taken by the image processing.
So any possibility for instrumentation engineering students?
Instrumentation, we have the sensors. So how they work? We have a lot of sensors, as I told in the car, as I told on the road. So communication, short range communication. So it is a lot of challenge for the electronics people, and then for the instrumentation, IT people, for data analytics, especially from transportation. We just apply, just looking at the volume of the traffic, what has to be done. We give the decision, but interpretation is done by us. But data capturing, everything, a lot of scope for the people to work on this area. It's one area that really, just like our medical field, if someone is suffering from cancer and you want to just have a 1 mm layer of skin to be removed, you are using robotics. So just like that, transportation is one field where there is a lot of scope for the electronics and for the data analysts to work with, and it will be really, you can see on the field what results you are achieving. It can be transformed to the field, and really you can see with your eyes the benefits. Yeah, that's one area.
Thank you.
Okay. So I think we are done. Any queries, I am available here only. You can just put a query by email or something like that, or any chance of a particular discipline application, we will be happy to answer. Thank you.